9077. Maximum range performance of a turbojet aircraft is obtained by which procedure as aircraft weight reduces? A. Increasing speed or altitude. B. Increasing altitude or decreasing speed. C. Increasing speed or decreasing altitude. The correct answer is B. Increasing altitude or decreasing speed. To achieve maximum range performance in a turbojet aircraft as the weight reduces, the typical procedure is to increase altitude or decrease speed. Increasing altitude allows the aircraft to operate in less dense air, which reduces aerodynamic drag and improves fuel efficiency. By flying at higher altitudes, the aircraft can take advantage of the thinner air to achieve a longer range. Additionally, decreasing speed also helps to optimize fuel efficiency and extend the range. Flying at a slower speed reduces the aircraft's drag, allowing it to cover more distance with the available fuel. Therefore, to maximize the range performance of a turbojet aircraft as its weight reduces, the pilot would typically choose to increase altitude or decrease speed, or a combination of both. 9323. Which is the correct symbol for the stalling speed or the minimum steady flight speed at which the airplane is controllable? A. VSO. B. Versus. C. VS1. The correct answer is B. Versus stands for the stalling speed or the lowest stable speed at which an airplane can be controlled. 9322. Which is the correct symbol for the minimum steady flight speed or stalling speed in the landing configuration? A. Versus. B. VS1. C. VS0. The correct answer is C. VS0 is the minimum steady flight speed or stalling speed in the landing configuration. 8374. What effect does landing at high elevation airports have on ground speed with comparable conditions relative to temperature, wind, and airplane weight? A. Higher than at low elevation. B. Lower than at low elevation. C. The same as at low elevation. The correct answer is A. The reason behind this is the reduced air density at higher elevations. As the altitude increases, the air density decreases, resulting in a decrease in aerodynamic drag. With lower drag, the aircraft experiences less resistance, allowing it to maintain a higher ground speed for the same power settings compared to landing at low elevation airports. It's important to note that ground speed refers to the speed of the aircraft relative to the ground and is influenced by various factors such as wind speed and direction. However, assuming comparable conditions including wind, temperature, and airplane weight, the reduced air density at high elevation airports leads to a higher ground speed. 9074. How should thrust reversers be applied to reduce landing distance for turbojet aircraft? A. Immediately after ground contact. B. Immediately prior to touchdown. C. After applying maximum wheel braking. The correct answer is A. Immediately after ground contact. Thrust reversers are typically deployed immediately after the main landing gear touches the runway. By redirecting the exhaust gases forward, thrust reversers help to increase the deceleration of the aircraft and reduce the landing distance. This is achieved by utilizing the engine thrust in the opposite direction, providing a braking effect. Applying thrust reversers prior to touchdown, option B, or after applying maximum wheel braking, option C, would not be as effective in reducing the landing distance. It is crucial to deploy thrust reversers promptly after ground contact to maximize their braking effect and optimize landing performance.